So, first I'm interested to know what is charge. Right? When I say charge, I'm talking about electric by default because we are in that branch. Right? So, what is an electric charge according to you? Where all did you see the word charge? You can think of your chemistry also. So when you talk about an atom, basically, what does an atom consist of? So you have a central core which is called as the nucleus, around which you have the orbits. The electrons are going to revolve in those orbits. I'm not going to the concept of orbitals. Let's stop with this. Okay. Now, if I take an electron here, this is going to revolve around the nucleus. Right. There are two questions that we need to answer. Right. So, what is the shape of the orbit? Circular. Right. Now, I want you to think and answer this question. If I drop this object, right? If I drop this object, what is the motion, right? What is the path it is going to take? Path means what is the geometrical shape in which this object will move. If I leave it like this, it will travel like this. So what kind of a path? It's a straight line path, right? So for you to have a straight line path, if the force is exerted in that direction, the object will get pulled in that direction. Which force? Unbalanced force, right? Whereas if I'm interested to make the same object move in a circular path, how is it possible? I have this, right? I have a charger, which I'm going to release, is going to travel in a straight line path. If I connect a wire here, right? I'm connecting it here. Now I'm holding it here, right? Observe. If I release it, what will be the path? It will be a curved path. I don't know what is the name of that curve, right? So it is going to be curved path. It is traveling like this, right? So what exactly is happening here? There is an unbalanced force in this direction, but what is making the object's direction change? Initially it didn't change, but when I connected this, its direction changed. Who was responsible for that? It is the tension which was acting here. Am I right? So mg is acting in this direction, tension is acting in this direction, due to which there is a resultant force acting in this direction. You know the parallelogram law of vectors, right? One vector, second vector, resultant along the diagonal of the parallelogram. It started moving in a particular path, right? So one thing I am clear with is, for an object to move in a circular path, there should be a force which is in the other direction. Right, I don't know which direction. So here if you see, the object is actually having a velocity v, right, assuming it is revolving in the anti-clockwise direction. Can I say that there is a force acting in this direction? Logically, why? Simple logic, you already know this concept. What is the charge of an electron? What is the charge of a nucleus? Inside nucleus, who is responsible for the positive charge? Protons, right? So neutrons are neutral, obviously. So there is a force existing in this direction. So can I say that the nucleus is trying to pull the electron towards itself? But is it succeeding? No, because there is a direction associated here. This force is able to change the direction, but it is not able to make the electron fall into the nucleus. So what is the name of this force? You call it as, in this context, you call it as centripetal force, right? Centripetal force is a generic force. Centripetal is something like this: center seeking. A force which is always towards the center is called a centripetal force. But in this context, in the previous case when I asked you, you told me that tension was the one which was responsible to make, assuming that curved path is circular, tension was the one which was responsible to put it in the circular motion. In this case, who is responsible? There also it is centripetal force only. So that centripetal force can be provided by tension, it can be provided by magnetic force, it can be provided by friction. Any force can act as a centripetal force. That's why I told you centripetal is a general term. But there should be a specific force which is providing the necessary centripetal force. What do you think is providing here? You're there. What is it? It is the electrostatic force. So this force is called as the electrostatic force. So in this context, the electrostatic force is the one which is responsible for the necessary centripetal force for the electron to revolve around the nucleus. Okay. Okay, I went slightly away from the context. Coming back to the context, now what is an electric charge in the first place? Right. So I am able to understand that if I have to speak about the charge on an object, I need to speak about an atom, because atom is the only place from where I am able to have both positive and negative charges. Right. Suppose I take an object, right, of some random shape. Right. Suppose I say this object is positively charged, this object is negatively charged. What is the meaning of it? What is the meaning of it? If we are able to think from an inner level, we'll get an answer to what is an electric charge. Suppose you look at the system, right, which is called as an atom. So if I look at the system of an atom, I have positive charge and negative charge within the same system. Right. So, when will I call this kind of a system as neutral? When the amount of positive charge and the amount of negative charge are the same. Right? So, when can I say that the object will be positively charged? I'll give you a hint. See, somebody put that question to me, I'll think it two ways. I can say positive charge is possible when I have excess amount of protons or deficiency of electrons. Both are right. When this is an excess, this is a deficiency. Similarly, when I say something is negatively charged, I can say there is an excess amount of electrons and deficiency in protons. Right. Now we need to think of a question. If at all I need to make an atom get charged, is it possible for me to give positive charge to that material or remove negative charge from that material? I want a material to get positively charged. Is it possible for me to give more positive charge? When I say more positive charge, I am trying to increase the number of protons within the nucleus. Or I can have deficiency of electrons, meaning I am trying to decrease the number of electrons in the orbit. Which one is easy? Why? Outer motion. Inside, the protons are not held by the, that is the reason why I use this word. Electrons are held to the nucleus because of the electrostatic force, but the protons inside the nucleus are held due to the nuclear force, which is many-fold stronger. You're able to understand what I'm trying to say? So, whenever you talk about the material getting charged, what is it we actually do? We either remove an electron or add an electron. So, when I say positively charged, what can I say? Can you give me the conclusion for this? There is deficiency of electrons. So when I say deficiency of electrons, you can say the number of protons are more. But here, what do I mean by deficiency of electrons? Means I am removing an electron. So to put it more simple, right, I will say removal of electron. This makes more sense. What about this? Addition of electrons. So you will have excess of electrons, which means addition of electrons has taken place. Right. So when I talk about these 2 points, it is giving me an answer to one question. Whenever either of the things happen, what will these materials try to do? See, when something is neutral, when everything is balanced, right, it will be calm. It is stable. That's what chemistry says. Right. If an electron is excited to a higher level, what will happen? Will the electron be at the excited level? No. What will it try to do? It will try to release the excess energy and come back to the ground state. It will always try to be stable. That is the basic nature of science. Here it is stable. What about this? Is this going to be stable? What will it try to do? It will try to search for the negative charge and go pair with it. What about this one? It will try to do the vice versa. Right. So, when I say they get combined together, can I say the positive charge or negative charge will start exerting force on the neighboring particles? Are you able to understand what I am trying to say? Positive charge or negative charge will start exerting force on the neighboring particles, and that property due to which it is able to exhibit that kind of a force is what is called as charge. Okay, nobody will ask you the definition of charge, but it is important for you to understand. Right? I'll come again. What did I say? Whenever a material is charged, right, due to that property, what will happen to it? It will try to exert a force on the neighboring particle, right? And due to which property is it exhibiting? Due to the property called as electric charge. So, consolidating all this information, if I have to give you a definition to what it is called as something called as intrinsic. Intrinsic means naturally occurring. Okay? Intrinsic property due to which, what is it doing? It exerts force on neighboring particles. Right? We'll visualize this, okay? We'll visualize this. Neighboring particles. So this is the definition of electric charge.